Okay, in this example, we start off with a battery. We have 24 ohms. We have 8 ohms and 2 amps. And this question says, determine the total power dissipated by the circuit and by each individual resistor. So because of law of conservation of energy, if we can figure out the power dissipated by each of these individual resistors, that's going to be the total power that's dissipated by the circuit. So we're trying to figure out the power of the first resistor and the power of the second resistor. So I'm going to call this just R1. I'm going to call this R2. So the given information that we are given R1 is 8 ohms. We are given the fact that I1 is 2 amps. Okay. We're also given R2 is 24 ohms, and that's really all we're given for R2. Now I could easily find the power using one of my formulas there, but you should realize that the fact that this is a parallel circuit tells us a little bit more information. Because it's a parallel circuit, if I can solve for the voltage there, it's the voltage here and vice versa. So really what I want to do is I want to say, okay, the voltage I can solve using Ohm's law, which is V equals IR. And I'm going to do that for the first resistor. I'm going to say V is equal to 2 times 8, which is 16 volts. So that gives me 16 volts here, 16 volts there. So now I have the voltage in the first branch. Okay, so that would give me 16. And I have the voltage in the second branch, which would also give me 16. So now what I can do is I can solve for the power in each one of these resistors. Now, since I have everything in the first one, I'm going to use the simplest power formula, which is P equals IV. So I would take 2, multiply it by 16, because P equals IV, or 2 times 16 would give me 32 watts. For the second one, though, if you look, I don't have the current. Now, I could solve for the current using Ohm's law and then plug it in, which a lot of you are comfortable with, and you could, of course, do that. But I'm going to go ahead and use my other power equation, which is P equals V squared over R. So I look at my equation and I say, okay, 16 squared divided by 24. And when you do that, you get something like 10.74 watts. So the powers dissipated by the two resistors is you have 32 watts by this one, you have 10.74 watts by the other one. So you take those two, you add them together, and the total power that's dissipated in this case would be 42.74 watts.